Hello, we're going to do a problem with heparin based on weight. When we read the problem, we have a client who weighs 135 pounds. Our order has two parts. We are to do a bolus with heparin sodium at 80 units per kilogram. A bolus is an IV push, so we'll use a syringe to measure that. Then we'll initiate a drip at 18 units per kilogram per hour. We have an IV bag over to the left, and we also have a label for a vial of heparin that could be used for the bolus. The first piece that we're to find is the heparin bolus dosage, and we're to find it in both units and milliliters. So we'll start with the 80 units per kilogram that is ordered. Now, because this is per kilogram, we'll recognize that we need to convert the patient's weight into kilograms. So up here at the top, I have the patient's weight of 135. So we'll convert that using the fact that there are 2.2 pounds to 1 kilogram. And so I'll divide that on my calculator, and I come up with an answer of 61.4 kilograms. Because this is greater than 10 kilograms, I'll be rounding to tenths. So back to my problem, 80 units per kilogram for the bolus, and I want to get to just units, so I'll multiply by the 61.4 kilograms, and that will allow me to cancel the label of kilograms. So I multiply on my calculator, and I came up with 4,912 units. So that is one of the answers that I'm looking for, because it asked me to find this in units. Next thing it asked me to do is find this in milliliters. In order to convert to milliliters, I have to know which med I'm using. Since this is the bolus dose, and that's going to be given with a syringe, I'm going to use the vial down here that has a strength of 10,000 units per 1 ml. I'm going to continue my dimensional analysis from this answer that I have. So I put units on the bottom, and there are 10,000. Please use your comma to make sure you get all the right zeros, and then we're not allowed to abbreviate units. 10,000 units, 1 ml. Cancel out my units, and I do my math. On my calculator, I get 0.4912. Since this is less than 1 ml, I'll round it off to the nearest hundredth. So my answer is 0.49 milliliters. So I truly had two answers in this problem. The one is the 4,912 units, and the other one is the 0.49 mLs. Next, I get to move to the IV drip rate. Again, I'm supposed to get two answers, one in units per hour, the other one in milliliters per hour. In the initial problem, I find that the order is for 18 units per kilogram per hour. When I have a triple layer fraction, the first label goes on top, so 18 units, and the other two labels go in the denominator, kilogram, hour. So I will multiply by the weight of 61.4 kilograms. This will allow me to cancel the label of kilograms. So I'll go to my calculator, do my math, and I come up with 1,105.2 units per hour. So this is one of the answers that I want. Next step is to convert this over to milliliters per hour. In order to convert to milliliters per hour, I need to know which med. Since this is the IV drip, I'm going to use the IV bag up here. In the IV bag, I see that there's a volume of 500 milliliters, and there are 25,000 units of heparin. So I bring this information down and continue my dimensional analysis. In the denominator, 25,000 units of heparin, and we know that that is contained in 500 milliliters. This allows me to cancel the label of units, and I go to my calculator and I do my math. When I look at my calculator answer, I want to round this answer to tenths because I will be typing this on an IV pump. And so rounded to tenths, I get 22.1 milliliters per hour. And so I have both answers that were requested. I have information for the bolus, how much they get, and how much I'll administer, so both the medication and the volume. And then information on the IV drip, how much they'll get, and then how I'll administer that, the volume per hour.